Hello everyone, welcome to Proceeded. So today we'll be studying about, you know, we'll be studying about cyclic detection in both undirected and directed graphs. So first let's go with undirected graph. So basically what is a cycle? So wait, first let me write the okay, so next we have like first we'll be checking this in undirected graph. So what is a cycle? Everyone knows basically a cycle is you start from a node and you end at the same node by going from either of the direction. Basically in undirected graph you can go from either direction, but in directed graph you have to like uh, go in a single direction. So first let's see how we can solve this question, or what we can do to solve this question. So basically suppose if I have this graph 1 2 3 and then 4, so there is no cycle. Now suppose I join this with this, so there is a cycle now. From 1 to 4 3 we can already reach 1 again, and similarly from 2 we can reach 2 again, and for 4 also, and 3 and 1. So cycle means if we can reach uh, from one node to the same node by following a path which also gives us the liberty. Gives us the liberty. So now, well, basically, I'll be telling you what liberty we have if we have this by following a path. If we can reach from one node to the same node by following a path, then it is called cycle. So about our gain, or we can say what liberty we have. So basically, if you want to reach from two, or from any place to the same, you can always reach in the same cycle. So in a cycle you will always be able to reach node from anywhere. So that's actually quite useful. So if you ask me what are the applications for this, so obviously one is the map, and secondary we have like, suppose you train your model suppose you want to train your model on dataset 1, and then you travel, like you want to like confuse the model, so you will be using a cycle. Basically if you have already completed over here, then to like what do we say that, yeah, so basically when you do epoch equals 10,000, that time we are looping each and every data set that many times. So basically we are forming a cycle for 1,000 times. So and after 1,000 times, so once we have traveled the same graph 1,000 times, then we can like exit from there. So basically that's what we are doing in cycle. So now suppose if there was no cycle detected, then you won't be able to train it more than once. So at that time, to save memory, you can just like if cycle not detected, then you can exit. Then you can exit directly without moving 1,000 times. So that quite useful. But yeah, no, in training dataset you can always go from one again and again. So basically for cycle you only have, well, basically you don't have any actual use for cycle. But yeah, you should know this because it's been asked in competitive program. Well, Like whatever we can do with the cycle, we can always use the same path again and again. So it's kind of not very useful if you ask me. But yeah. Okay, so let's go to the code for undirected graph. So if I ask you how can you travel this? So first, many of you might be thinking that we can use DFS. So like I've already told you that DFS is not a very convenient method, but if you want to use DFS, then we can always like go with that. Well, basically DFS is not a problem, but sometimes it's not useful. But over here we'll be using DFS only, but yeah, you can like travel with other stuff too. Anyways, so what I was saying is, well, basically here you just go in a single direction, and then if you meet the same side, then you get that it was a cycle. But if you try to do that in BFS, then you might face some problem. Now suppose if you go from here to there and you also travel from here, then you will ultimately meet a point where you have already traveled the thing. So over there, when you say that if it completes a cycle, then it might be wrong for that. Or you can say that it's correct, but yeah, like one way or the other, it's kind of problematic. Like DFS is easier to implement than BFS over here, because BFS is actually a small block of code. So yeah, so basically you can also do it with BFS. That's not a problem. Okay, so what I was saying is, well, basically just the logical change. Like you have to travel both of them, and then when you reach the same point, then you can say that these were the connected parts, or you can say these were the parts of your cyclic graph. So once using the DFS method, what you can do is basically you can have a visited array. Okay, so this one node, visited node. So you can always travel with the visited node. And what you can do is if not visited, and so on. And also if is cycle, then return true. Basically, if that was a cycle, then we can return true always. For each and every node, we can do the same. And next, what you can do is if neighbor not equals to parent, or you can say if neighbor node is not equals to parent. Well, basically, we'll be having a parent node also. Then we can say that we can also return true over here. Basically, this is the main code, this neighbor and parent. Rest we are just doing it like backtracking and other stuff. But yeah, this is the main code. And then if none of that worked, then obviously there was no cycle to begin with. So we can return false if we need. So I'll be writing the code for whether it is cycle or not. Then we'll be checking whether for that index it will be cycle or not. So we can just like check if it is cyclic for that index. And if suppose you are asked for connected components, then what you can do is you can basically write this over here in the for loop, and then you can check for each index, or you can say each node, and then we can just get whether it was a cycle or not. And similarly, you can count the cyclic count, how many cycles were there. So each and everything I'll be showing you right now. So first question first, you have to find whether the graph is cyclic or not. Basically, whether a cycle exists in graph or not. Or you can also frame the question like this: is graph cyclic? And second question, how many cycles are present in the graph. So if we have time, then we'll be discussing the second question today only. There was one more question last time, but uh, like this one was too easy, so I just didn't write anything for this. So you already know that how you can check even for n percentage 2. If there was no remainder, then it's even, and for f percentage 2, you can say if the remainder was not not 0, or you can say 1, then you can say that it was odd. And similarly, you can just like check whether the whole island was pass or not. So that's not a problem. That's not much of a problem for now. Okay, so let's first quickly check what we need. Okay, so here I have like first this one, whether a cycle exists in graph or not. So for that, what we can do is we can write this code over here, and then we can just keep checking. So first let me write the code, and then we'll be meeting back again. So okay, so I'll be pausing this so that we can just save time. You can try it yourself. Okay, so now I have written the code. So let's check what we have over here. Basically, we just check whether it is cyclic or not. So first we check the same thing, visited node equals true. The only difference is the only difference we have over here is just this. Okay, so the only difference we have is like this thing, parent over here. So we just are checking whether there exists a parent or not, and then we are checking for the node. So what you can do is you can basically write this code and then check what I've done. So basically for today, let's keep it just this much. So tomorrow we'll be going on the second part of the question, which is counting how many cycles are there. So for now, thank you for watching. Thanks everyone. Thank you.